All right, now everyone should have this copy of the notes with the summary stuff here. Now we are done with circles, and we are done with ellipses. Okay, that's the next page. Now it's very important that you are able to draw these shapes and label them at all times until the end of next week. Okay, because the test will be on next Thursday, not this week, but next week before the long weekend. Okay, it's very important that you know how to label them because that's how you know what the A, B, and C values are for. And if you want to wait until the very last day to cramp everything together, I would tell you that it is going to be ominous. It's going to be dreadful. It's going to be crazy. And you will feel extremely frustrated because of what we're about to learn today. We are going to learn about parabolas today. And we still have A, B, and C's, but the shape, it's just different. The way we label our A, B, and C, somewhat different. And therefore, if you want to wait until the very last day to cramp everything together, it's not a good strategy. Okay, so after today, I expect that you can write the equation of a circle. At any time, you can draw a circle and tell what is the center. Okay. You can draw ellipses, vertical and horizontal. You can write equations for those. And you can write down what A, B, C values are, and you can write down the equation between A, B, and C. What's the equation that relates A, B, and C together? C squared is equal to A squared minus B squared. And if you ever doubt yourself about the different the relationship here, okay, how can you tell that it's A squared minus B squared, not the other way? A is always the largest. A is the largest, so the A has to be the longest. So A squared minus B squared will give you the C squared. Now, for hyperbolas, so we have these. And let's go ahead and do a little bit more of a precise labeling. Now, the A value is between the center and the vertex. Now, there are only two vertices here. Only two vertices here, and the distance from the center to the vertex, it's always labeled as A. And for hyperbolas, A is not the longest among A, B, and C. A is not the longest among A, B, and C. Okay. Now, this is known as the conjugate axis. Okay, so earlier when we talked about ellipses, we have the major and minor axes, and now we have the transverse, the main one, the one that touches the vertices. That's the transverse, and the other one that doesn't touch any point of the graph, that's called the conjugate axis. And that, it's B. Now, it's very important that you know the A and B values, because if you know the A and B values, you can create something called the box. Oops. Yeah, let me just do this. This is the box. Okay, although it's two-dimensional, but we still call it the box. Now, why is it important to create the box? Is because after you have the box, which has a length and width of 2A and 2B, you can then draw the diagonals. And the diagonals will be very important for you to draw your graph, because so far we just have the vertex, right? Or the vertices on both sides. And so how do you draw a graph? Well, the graph is going to lean towards the asymptotes. So we have two asymptotes here. Those are the diagonals of the box. Okay. And then we also have two foci. And foci it's there, and it's always C units away from the center. Foci, it's always C units away from the center. So that's still the same with the ellipses. From center to the focus, it's your C value. So the main difference is really the A and B. Okay, they look very different. Okay, and among A, B, and C, which one seems the longest? C seems the longest, and that's why the relationship between A, B, and C, it's now A squared plus B squared, it's equal to C squared. It's an addition, not a subtraction, because C in this case is the longest. Okay. So that's the labeling part. How about the equation part? So you have these two equations right here. Okay, the horizontal and the vertical hyperbolas. So one way you can tell the orientation, well, first, before you can tell the orientation, you can already tell that there's a subtraction between the two fractions. So you cannot mislocate them because it would be something totally different. And how do you tell something is, how can you tell a hyperbola that's being oriented horizontally? Yeah, the x goes up front. So if the x goes up front, horizontal. If the y goes up front, it's vertical. Okay. What about the placement of A and B? Well, the A is always from the center to the vertex. So, well, A would always sit up front. Okay, that indicates the value from the center to the vertex. So think about this. If it's a horizontal hyperbola, so it's going to be like this. Well, this is going to be your A value. If it's a vertical hyperbola, so that's the center, this is the A value. And again, always sketch out the shape, just to remind yourself what it is. Last period, I was doing one problem, and then it was supposed to be a horizontal hyperbola, but then I drew on the graph as a vertical hyperbola. And then after a while, I realized that, wait, hold on. How come the graph that I'm drawing doesn't match with the sketch that I had earlier? So then I realized something is wrong.
I was going to say, I thought vertical.
Like this is the vertical.
Yeah, I thought it would be.
Position, like you mean this is vertical?
Yeah,
How?
that's what I thought.
Now the way I like to think about this is the graph is going to keep on going, right? So that gives you a better sense of vertical hyperbola. Okay. All right. Now, so that's the little summary. I would suggest you to use this page to guide your labeling. It's very important to label things. We still have eccentricity equal to C over A. We still have the length of lattice rectum being 2B squared over A. That's the same. That didn't change. Okay. That didn't change. Now, we will write down the equations for the asymptotes. Well, how? How? The first thing that you need to consider is, do you still remember the point slope form of a linear equation? Point slope form, anybody? No one? Point slope form. Now, if you say, I have no idea what point slope form you're talking about. It's so long, it's such a long time ago. Now, I will tell you this. I got scammed by my math teacher when I was young. So I learned all these forms back in Algebra 1 level math, and then they all left me right after Algebra 1. And then when I learned it some years later, like in pre-calc, and then you will use point and slope form a lot in calculus, by the way. And that moment, I saw the point and slope form again, and there was a spark. Now, let me ask you a question. How do you calculate slope? Rise over run, right? So which means you have y2 minus y1 over x2 minus x1. Now, everybody knows how to calculate slope. And if you know how to calculate slope, then there is really not a reason how you don't know the point slope form. So the only reason why you don't know is because your Algebra 1 teacher didn't tell you where the point slope form came from. So that was a spark. So I was staring at the point slope form myself when I was when I was in pre-calc. I was looking at this. And I was like, wait, hold on. Something looks very, very similar to each other. Can you see the connection between these two equations? So what happened was that we multiplied the denominator to the other side. And that becomes a point slope form. And we just change the x2 and y2 to just x and y, because for an equation, we need the x and y. So therefore, all you need to insert right here is the y value of a point, x value of a point, and then whatever slope that you have. That's your point slope form. So again, if you know how to calculate slope, then there is no reason how you don't know the, well, if you know the slope equation, then you must know the point slope form. It's just that do you have the connection to draw them together? So what do we do in this case? Well, if you look at the asymptotes, they always pass through a point. What is that point? They both pass through. For these two asymptotes, they both pass through the center. So they both pass through the center. So instead of saying y1, we'll say y minus k, the k value of the center. Now we'll take care of the slope in a moment. And then we have x minus h. Now, what about the slope? Now there are two asymptotes here. So we say, all right, let's get the rise over run. Let's get the rise over run. What is the rise over here? That's a b value. What's the run? That's a value. So the slope in this case, you can write it on the paper. The slope in this case would be plus or minus b over a. Now, please do not memorize this. It will drive you crazy. So instead, just focus on drawing a good picture and let the picture tell you what the slope is. Okay, again, the rise is a b value, the run is your a value. Therefore, you have rise over run, b over a, plus or minus. Okay, now what about the other one? Well, let's label this. This is your a value. This is your b value. So if you look at the asymptotes here, so you have a plus and minus. So we ask the same question. What is the rise? That's your a value. That's your b value. So rise over run will be a over b. So this is something that your picture could tell you. You do not need to memorize them. And I do not suggest you to memorize these slopes. It's just so easy to mix up, to confuse, and there's no point to memorize them because you have to validate them anyways. Okay. So depending on the parabola, you have to come up with these two slopes. So I'm going to leave the M over there for the moment. Any question about all the labelings here? Tedious. Okay, so that's why I said you need to practice all these labeling. Okay, you do not wait until the very last day. That would be a major disaster if you wait until the very last day. Now, if you flip to the next 2 pages, you also, is it next page? You should see this one with hyperbola at the very top. Now, I want to address something because I realized something, it's printed incorrectly. Now, there are 2 diagrams at the bottom. What I want you to ignore, I need you to ignore this diagram because it was made on Microsoft Word and it somehow got messed up, the orientation, so the box is all off to the wrong places. So that is not an accurate drawing. The one on the right, yes, but I would say we may as well just use the one on the previous page. Okay, this one would be a much better summary than these 2. Okay, so at the bottom you can see why we have these asymptotes. Okay, so one is plus or minus b over a, the other one is plus or minus a over b. So make sure you understand why we have a over b or b over a for these 2 scenarios. Okay, so next up we will start doing some practices to get the equations from general form to the standard form.